The statements on the left, so this is things that you know are true, and the reason on the right side. Does that look familiar? Something we did yesterday, maybe? Remember you wrote the letters, how you were changing it, and then what'd you put on the right side? Which rule, right? So same exact thing for a proof. You put things that you know are true on this side, and then the rule, the reason you knew it was true, on the right side. So this is how typically proofs look. It's going to give you given information. That's something you know is true because it told you. Then it's going to tell you what to prove. So kind of like this is the first letter. We're going to start with a C, and I want you to make it a B. So just like the letter proofs, it gives you a starting point and an ending point. Then typically there's a picture that shows visually what they told you in the givens. So are you ever going to write a proof in your life after this? No, you're not. Okay, I know that. But have you ever had to process information and argue maybe your point or defend something, like in an essay? Have you guys written essays before, like a research paper?
Unfortunately.
Yeah. You typically, right after you quote something, have to do what? Explain it with and you have to show where you got it from, right? Is that called a citation? You put in parentheses where I don't remember how to do it, but like the author and then the page number. So this is, here's a statement I know is true. Here's where I got it from. Proof is the same exact thing. A lawyer, do you think they can just show up to court and say, I know this person stole the car, and that's it? Or do they have to prove it with evidence? Right. So even though you're never going to write a mathematical proof again, I know that, the process of thinking about how to form an argument is very useful, okay? So in geometry, all of our rules are called properties, postulates, theorems, definitions, things like that. So these are rules that we have given to us. Like yesterday we had 3 rules. You know what I'm talking about? You can change any letter to an A. That was a rule. These are all rules for our geometry proofs, and there are a lot more. That's why I gave you that chart to put the rules in your own words, because this looks confusing, right? This will be provided to you on a test, anything that's in a box, but instead of using that, I would use the chart that I gave you that's written in your own words, okay? So I'm not going to go over addition, subtraction, multiplication, division, because I think you know what those mean. These are the ones I really want you to understand today. So those are the ones I wrote on the board, and I'm going to write it here as well. So I'm going to go kind of fast. If I go too fast, just take a picture of it later, or you can watch this video back. So the first one is called reflexive. And this means that the same thing on both sides are equal. So like if it was A equals A, that's the technical way the rule is written. It says that something is the same as itself. And that sounds really weird, but you'll see how it applies later. So some examples, 5 equals 5, AB equals AB. That one we're probably not going to use today, but you will eventually. Okay, next one is called symmetric. Like I said, I'm going to go kind of fast, so you can get these down later if you need to. So the symmetric property says that you can flip any equation and it's still true. So I'm going to put flip equation on the explanation. The technical way it's written is like this. If that's true, then this is true. So for example, if 5 equals x, then x equals 5. So these are all rules to say that if these are kind of written with if-then statements. That's why we did that entire chapter with if-then, to get you thinking about it, because the rules are typically written like that. If 5 equals x, then based on this property, I know that x equals 5 too. I know that's true too. The next property is called transitive. I put a star by it because it's used a lot. So I'd probably do that. So the technical way it's written looks like this. Do you want me to just write it in my own words?
Yeah, that's the simplest way.
Okay, so let me use some numbers and letters. If x equals 5 and 5 equals y, then based on this property, I know that x equals y. Does that look like anything we've done before? Remember the law of syllogism, where we tied the two if-then statements together and said the first piece, if the first thing, then the last thing, we can tie them together? Same exact idea. If x equals 5 and 5 equals y, these two match. So x and y have to be the same too. So I know that. So instead of calling it the law of syllogism with if-then statements, this is called the transitive property with numbers. So for example, pretty much the same thing. I'll just give you another one. If AB equals 10, so that's the length of a line or a segment, and CD equals 10, then you know AB equals CD. Since they both equal 10, they have to equal each other. That property makes sense? Like I said, you're going to feel maybe a little overwhelmed while we're writing these because you don't understand how they're used, but you will. Substitution, I'm starring because it's used a lot. So what does substitute mean?
To replace.
Replace, right?
Shortly.
If I'm not here, I have a substitute, right? So if two things are equal, so they're not me, but they're also a teacher.
When does it change?
11. Actually, maybe it's 5 till.
It's 10:54.
Okay, you can go if you need to. Substitution means that if two things are equal, you can replace them with each other, right? So I'm just going to put replace here. We can add to it if you want to, or if you want to write more in your own words, you can. So for example, if x equals 5 and it tells you 2x plus 10, then you could take the x out and say that this is true. So I took the x out and replaced it with 5 because they're equal. Does substitution make sense? Okay. The last one, this one is technically not a property, so this is, not only is it beneficial to have this chart because you're writing it in your own words, but we're going to add some things that aren't really given to you on the test, like this next one is not. This is called combined like terms. And for short, I usually put this, CLT. So you use this when you combine terms on the same side of the equal sign. So for example, 2x plus 3x equals 10. If that's true, then I can combine those and say that's true too. Okay, I think you're going to start getting the hang of this once we start some problems. Again, this feels like just a bunch of information that you don't understand, but you're going to understand it once we start applying it. So if you didn't get all that down, get a picture of the board. It's all up there. So the first example, we're going to complete statements. So it's going to give you a property that it wants you to use, and then you need to complete the statement below. So it says use the reflexive property to complete this. This says the measure of angle Z, even though it doesn't really look like it. So reflexive property says what? Look at your chart.
Measure of angle Z is equal to measure of angle Z.
Yep. Reflexive property says that something is equal to itself. That's it. Okay, division property. I didn't go over this because I know you know what division means, but within an equation here, it's saying use division to change this equation to kind of simplify it. So if you divided here, then what would you get?
We don't know our division.
It's 7. So if 12 times x equals 24, then based on dividing, I know that x equals 7. Okay, transitive property. Look at your chart if you don't remember which one that is. So if the measure of angle 1 equals the measure of angle 2, and the measure of 2 equals 3, then transitive property says what two things are equal?
2. M is equal to M, right?
It's the whole thing. So what number angles would be equal to each other?
Then measure angle 3 is equal to measure angle 3.
No. Look at the chart up on the board or on your own. So if x equals 5 and 5 equals y, then x equals y. So we're taking out that matching piece and tying the other two together. So can you relate that to this one? See how they both equal the measure of angle 2?
Yeah.
So if they both equal the same thing, aren't these two the same?
I guess if you subtract.
So measure angle 1 is equal to measure angle 3.
Yep. So you're tying those two together, just like the law of syllogism when they matched. You could take that match out and tie the first one to the last one. Okay, number 4. This one's on your own, but I'm going to go ahead and do it with you. Substitution says that you can replace something in an equation as long as it's equal. So this tells me that if x equals y, that means I could take x out of any equation and put y in its place. So I could take this x out. What would it say?
3 times 5.
2y plus y equals 5. You don't have to solve it or anything. It's just telling you to use that one property. Does that one make sense?
No.
Okay, substitute, remember, means I can replace. So this tells me that x is the same thing as y. So I can take x out of any equation, like this, and put y in its place because they're the same.
Oh, okay.
Okay? Now we're going to go backwards. It's going to give us the full statement, and we have to figure out what property was used to get from here to here. So what did they do to this equation to make this one? Yeah, they subtracted the 14, right? So that's called subtraction. If you're feeling confused right now, the good news is I think this part's harder than the proofs. Okay, 2, what do you think they did to get from this side to this side? Distribute, yep. Okay, what about 3? What property says that if ST equals QR, then QR equals ST?
Substitute.
No.
Symmetric.
Symmetric, why?
Because the
It flipped, right?
yeah.
So anytime an equation flips, that's called symmetric. Because it's the same thing either way you write it. Okay, look at 4. How did they get from the equation on the left to the equation on the right? They added BC over to the other side, right? So that would be addition. Okay, now that we've gone over the properties, we're going to apply them to a proof. You ready?
No.
Every class so far has thought that this was easier than they expected based on what just happened. So it's going to give you an equation to start with and then tell you what to prove. So every proof starts with the same exact thing. Any idea?
Equation.
Yes? Whatever's given to you, right? So you're going to make a 2-column chart. Statements go on the left. I typically just put an S. The reasons or the rules that we're using go on the right, just like the letter proofs yesterday. The things you know were true were happening on the left. The rule was going on the right. So the first thing you start with is the given. So that's 3x plus 5 equals 17. Oh, number them. It's a lot easier to grade when they're numbered in case they're not perfectly lined up. Then I can tell what rule goes with what statement. So how would you solve that equation?
Subtract 5.
Okay, so you don't have to show work in a proof, you just need to show the next statement. So if you subtracted 5, what would you get?
12.
So it's 3x equals 12. And what rule did you use?
Subtraction.
Subtraction. Okay, now what would you do?
Divide 12 by 3x.
Okay, so what do you get?
4x.
4.
Or x equals 4.
Yep. What rule did you use?
Division.
Division. Are you finished?
Yes.
How do you know when you're finished with a proof?
You have your answer.
Yeah, it tells you up here what you're supposed to end with, just like the letter proofs did. At the bottom, that was your goal, right? This is your goal. So we made it. You're done.
So you just solve it, pretty much.
Yep.
So it's kind of like algebra in a way
Today,
of solving. Oh, today. Okay, nice.
we're starting with something you know how to do and applying it to a proof. Eventually, we're going to do things you haven't done before within a proof. But this is that made-up unit. I don't know if I told this class about it. We created an entire introduction unit to proofs last year so that it would be easier. Okay, number 2. So again, where do you start?
Statements and reasons.
Okay, what goes first?
The equation, what you were given.
Whatever you're given. This one has 2 things. Sometimes there's one, sometimes there's more. So whatever is given to you, you list all of them. So negative 6x minus 5 equals negative 95. So that's given.
Wait, what do we do with x equals y? If I'm not-
That also goes as a given. So if it gives you more than one given, that means you needed both of those things to get to your goal. It's not going to tell you more information than you need. So look at our goal. It says y equals 15. Can you solve that equation and just solve it and get to the goal?
No.
Why not?
There's no y.
There's no y in this equation, right? But this given tells us that x and y are the same. So what could I do to this equation?
Turn x into y.
Good. So step 3, we're going to say negative 6y minus 5 equals negative 95. What rule is that?
Substitution.
Good. Substitution. So if you want to add to your chart, instead of just the word replace, when you take something out and replace it with something it's equal to, that's called substitution. Does line 3 make sense? Okay, how do you solve it?
Add 5.
Add 5. So negative 6y equals negative 90. What rule did we use?
Addition.
Addition. And then what? Divide. So y equals 15. Division. Are we finished?
Yeah.
Okay, look at, I'm going to skip over 3 because it's actually very similar to 5. So go down to 4. Start with your 2 columns. Start with givens. This time there are 2 givens again, so list them both first. Okay, I want you all to think. Don't say it yet, because I want everybody to try to think about it. What would you do next? Don't say it yet.
Sorry.
So what ideas do you have? Okay, you could add 4. Any other ideas?
Solve the first one.
Okay, you could get y by itself there. Any other ideas? Could you do either one of those things?
Yeah.
Yeah. So this is where I get a lot of questions. How do I know what to do next? Just like the letter proofs, I know I keep going back to that, but it's a really good activity for proofs. Could you do something and then it not really be beneficial to you and you would have to start over with the letter proofs? Like, do you remember there was one that we could have changed it to an A? I don't remember if we did it in this class. But it was like a C, and we could have changed it to an A, and then we realized that wasn't helpful because we needed to keep the C. So what I'm trying to say is there's more than one thing to do here. Sometimes you're not going to know if it's beneficial or not until you just try it. So could you do either one of those things? Yes. Once you start doing a lot of proofs, you're going to start figuring out what might be helpful, just like the letter proofs yesterday. You started catching on to kind of the pattern. So my suggestion is to probably solve for y here. And then, well, I don't want to tell you. I'll let you figure it out. So how do you solve for y?
12 divided by 2.
Okay, division. So what do you get?
6.
6 equals y. That was division. Was that what we were trying to prove?
No.
Okay, so if we're trying to prove x is 10, that means we have to solve an equation with x in it. Can you solve an equation that has 2 letters?
No.
No. What can you do?
Substitute
Substitute what?
the y for an x.
You're on the right track, but you said it wrong. What can we put in place of y based on this line? 6, right? This tells us that y is the same thing as 6. So I can take any y out of an equation and put 6 in its place. So does this make sense if I take this y out and put 6 there? That makes sense to everybody? What's that called? Substitution. Can I solve it now?
Yeah.
What do I need to do next? Add the 4. So that would be 10 equals x. That was addition. So is line 5, 10 equals x, is that exactly what we're trying to prove?
Yeah. Well,
Yes, it's
We're
the
there,
same.
but it needs to do what?
it needs to flip.
Do we have a rule that does that?
Yeah.
So it seems silly, I know, but this has to be exactly the same. So if it's backwards, we have a rule that flips it, called what? Yep. Are we finished now?
Yeah.
Yes. Okay, we've got 2 more. You feeling a little bit better about proofs? Okay, number 5. 3 givens this time. You might want to write a little bit smaller, because this one has more steps, I think. So list all 3 givens at the top. So we're trying to prove that x equals 6. Can we solve any of those equations right now?
The second one, if we take 3 divided by 12,
If we do what?
3 divided by 12.
Oh, we could do that if they were on opposite sides of the equal sign, but since they're on the same, you can't. So, do any of them have an x only?
No.
No. If there are two variables, you cannot solve it. So, can we solve any of them? No. So, we need to start tying some equations together so that they all have the same letter. So, do you see anything we could start plugging in?
Can we do 3 plus?
What?
Can we just do
What are you thinking, Garrett?
3x plus 12 equals ax minus 18,
Perfect. Why?
because a is equal to b.
Okay, and this line is A and this one's B. So if A and B are the same thing, can't we set these two things equal to each other? Okay, so do you want me to do this one step at a time?
Yep.
Okay, so I'm going to take the A out and put this in its place. 3x plus 12 equals B. What's that called? I took A out and replaced it. Substitution. Can I do the same thing with B?
Yeah.
Take B out and put that equation in its place. Oops. 5. So 3x plus 12 equals, instead of B, I'm putting 8x minus 18. Substitution again. So if you want to do both of those at the same time, since they're the same rule, you can. Any questions about that yet? How do you solve that equation?
Yeah, 3x minus 8x.
Yes, we need to put the x's together, right? So line 6, if you subtract that 8x, you get negative 5x. Now what? Minus 12. So negative 5x equals negative 30. Oh, sorry. What was this line? Subtraction, right? And what do we do here? Subtraction again. And what's the last step?
Divide.
Divide. So x equals 6. Division. Okay. You guys finished writing?
No.
Okay, I'll wait. Okay, 6, last one. I'm going to do this kind of fast because we've got about 4 minutes left. And if you want to just watch, you can, and write it down later if you want to watch the video. So I'm listing the givens first. Okay, can you solve any of those equations?
No.
No, they all have more than one variable, right? So I'm going to replace, and I'm going to do this all in the same step since it's the same thing. I'm going to take an A out and put this in its place up here. I'm going to take B out and put this in its place. What's that called?
Substitution.
Yep, so 4, here's A. And then take B out and put that in its place. Substitution. What do you think is next?
Distribute.
Distribute. So it'd be 20x plus 28. 12x minus 27. Okay, this step we haven't done before, so I want you to watch. What?
Like terms.
Yes, because there are variables on the same side, we're not actually subtracting that from here. Subtraction property means you're moving to the other side. We're on the same side, so we're combining like terms. So 17x plus 28 equals 12x minus 27. So that's when combined like terms happens. Okay, I think you could probably finish that by yourself. So I'm going to go ahead and pass out your homework. You would subtract the 12x, subtract the 28, and then divide.